so much for an amazing talk. I think it's very inspiring. So I guess like my main question would be that in working with creative people as like a vision or Gen AI researcher, I find sort of having those conversations or finding the right way to approach the conversations to arrive at the right tools is one of the most difficult things, right? Because they're stuck or sort of in their process of how to create, and then we have like all of this technical information, but not enough of an understanding of what they need. And I think in many of my conversations with them, it ends up being like they want like very small quality of life improvements or little things, and I struggle to kind of make them imagine the possibilities of like tools and like find that right balance in these conversations to arrive at really what should we build that actually impacts the creative workflow. So I was just wondering your thoughts on making these conversations happen and yeah, how we should approach it.
Yeah, great question. And I agree, it's not always easy. Sometimes just understanding the right language to be able to talk to, between the two groups is difficult. I had this experience recently where we talked in visual effects and film industry about a show. A show to us, even if we're working on a television series, is not just one episode, it's the entire series. And this was a point of confusion, and I realized, oh, we're using the same word to mean two different things. And that was the source of it, like almost an hour-long source of confusion. I don't know the answer, other than one of the reasons for me personally to leave tech and go back into the production side is to be able to work one-on-one with creatives and have that cycle of feedback just be much quicker and be able to make those translations on a hour-by-hour basis rather than a week-by-week or month-by-month basis. So that's been my solution, and I also did one of my last projects at Google before I left was creating a little animated short, which we had as a poster at SIGGRAPH last year, which was, there we brought in artists into Google, but it still felt like working through molasses trying to figure out what's the right way to bridge these two. So the only answer I can come up with is just tighten that loop, work as closely with artists as you can, bring them into your process, show them things on an hour-by-hour basis as they change, and that's, to me, the way to make things happen.
Thank you so much.
Hello, thank you for sharing cinematic experience with us. Just a fun question. Just wondering, I've noticed a lot of virtual productions, and you show the line where the practical VFX ends. Usually the practical stuff is foreground. I'm just wondering, what about generating even that as virtually? I'm just curious.
I think usually the foreground is created as a practical set because performers need to interact with it. That's typically the reason. I don't think there's really a technical reason. I will say that although the LED walls are getting much higher quality now, we still often have to put them just a little bit out of focus so that we can't see the pixels, and so that limits how close to the performers we can get, because it should look like it's a little bit fuzzy in the background. So, but I don't think that's not a long-term limitation. It's not a limitation in every case. It's just been a limitation when we use longer lenses, as you can see, more zoomed in the LED wall.
Okay, thank you Ben for your great presentation. So we can now proceed with Eli. As an introduction, Eli Shechtman is a senior principal scientist in the imaging lab, Adobe Research. His research lies at the intersection of computer vision, graphics, and machine learning, with a focus on generative modeling and visual content editing. His work has contributed to key features in Adobe products. He currently leads a team of researchers and research engineers at Adobe. Thank you so much. Is this on purpose? No.
Thanks so much, Osgur, for the introduction. Thanks for inviting me. Dan's talk was kind of, he brought SIGGRAPH into CVPR. I'll go back to a more typical CVPR talk, but hope it's going to be interesting. So, yeah, I'll talk about some other challenges that are maybe complementing the previous two talks related to video generation. So, yeah, you're all probably familiar with the state-of-the-art video generators, text-to-video generators, image-to-video generators. This one is from Firefly, but there are other companies doing that, ByteDance and Google recently with Veo 3. Sora, of course, started high-quality generators last year, etc., etc. So, and people are building all kinds of applications on top of that. We saw from fine-tuning and compositing or editing, and this is kind of style mix in Adobe's products, etc., etc. So, and the quality is very high, and this is all great. But still, there are several challenges with video that I'd like to address in this talk. And they're mostly related to kind of how do we really scale this to long videos. Basically, the latency or the cost goes quadratically or sometimes linearly with some recent state space models with the video length. So that's a problem. So if we look at applications like real-time simulation for virtual reality, for robotics, agents, embodied intelligence, this is a demo from Genie 2. We really need interactivity. We need to allow the user or the agent to change the video during its being played, or interact with some agent that gives it some level of control. Also for creative kind of users, like the ones from Adobe and other companies, this is a demo from Run AI. They would like to kind of rapidly prototype the video content as they see the result, during kind of watching the video. For example, changing the viewpoint of the camera, like you see here, or controlling the character, kind of doing things interactively. So with kind of common distillation techniques like consistency models and DMT from our group and other instant flow, etc., you can get pretty nice speed ups for video generation of up to factor of 20. But that's not enough. To get to real time or interactivity, you need at least additional factor of 10 speed up. So how do we do that? And if that's not enough of a motivation, I brought here an example that actually shown from my team, presented me basically from the home video market. Basically, if you're kind of as old as I am, you remember that many years ago we used to buy DVDs or CDs to watch video. Then people started downloading videos from the internet. And more recently, the last few years, basically streaming became the main method or way that which people watch videos, and that really took off. So what changed? Basically, we have faster internet, smarter codecs that allow kind of more optimized streaming efficiency. And I believe, and a few others believe, that kind of a similar thing will happen to video generation. Once we'll solve all the challenges related to kind of real-time generation, this will become the default. There's not going to be a way back to generating kind of slow, long videos. It's all going to be interactive and fast. But we're not there yet. We're getting there, and a few other startup companies that I show here are also kind of moving in that direction. So you've probably seen the demo by Oasis and Odyssey more recently. Magi, basically they're all kind of moving in that direction. The quality is typically still pretty low, and often these demos are shown on toy environments, kind of gaming data that they're tested on and trained on and tested on, or it's simply still far away from real time. So we're not there, but a lot of people are thinking and trying this. So I'll present here a couple steps in this direction that my team, with a lot of collaborators, worked on in the past year, I would say. So the first project is called, or we call it COSVID, Causal Video. This was done in collaboration with Tian Wei, who was an intern at Adobe, a student from MIT, with his advisors Will Freeman and Fredo Duran, and my colleagues from Adobe, Chiang, Richard Zhang, and Shun Wang, the main mentor of this project. So let's see what's the main idea of COSVID. Basically, let's look first at kind of a traditional video generator or text-based video generator. So you have kind of a video represented as a space-time volume. And you have noise as an input to all the frames, plus text conditioning. And the architecture is typically a diffusion transformer, although there could be others. And the important thing is people use this bidirectional attention between all the frames to all the other frames. And because of this bidirectional attention, generating the video, the entire video is very slow. It takes typically tens of seconds or minutes for a few seconds of video at high resolution and high quality. So that's most of what most of the generators do today. And that obviously leads to kind of a slow or large latency to see the first frame, to see the first frame of the video that grows quadratically in the naive way with the video length, and it's obviously not interactive. So what we propose here is to do things autoregressively. So it's an autoregressive diffusion transformer with causal attention instead of bidirectional attention. So we generate the frames one by one, so we denoise them one by one, and the current frame is always attending only to the previous frames and not to the future ones, the way videos are streamed. And that allows us to basically get negligible constant latency to see the first frame, so you can start watching the video as it's being generated. And the user, the more important thing, the user can interact with the video in real time as they watch the video. A little bit more detail, kind of what are the key components in the model. I would say there are three components. So one is, as I mentioned before, we use this causal version of diffusion transformer that is initialized from bidirectional, but then we make it causal. The next component is we use diffusion forcing from Chen et al. Last year. It's a pretty popular technique in video generation, where you add kind of different amounts of noise to different frames, and denoise basically all of them all together to use the training data in a most efficient way as much as possible. But the diffusion forcing also kind of tries to simulate what happens at inference. So at inference, we already generated the previous, say, k frames, and now we're denoising the current frames. So the previous frames are clean. So you need to see during training also clean frames in your history, which diffusion forcing includes. Basically, you have different levels of noise, so some of them are cleaner than others. So that's kind of the motivation here. And in addition, to get kind of a similar quality of the student model, this causal attention model, to the teacher one, we use a distillation technique. In this case, it's our own from my team, Tian Wei's previous work called DMD, Distribution Matching Distillation, papers from last year and 2 years ago, to match the distribution of the teacher model, which is bidirectional, to the student model that has causal attention. These are the three main components. More details are in the paper and in the poster that we're going to present on Friday. I forgot to mention poster 181. Sorry, not on Friday, on Sunday. So this is kind of a demo of the results. Basically, on the left, you see the teacher bidirectional model, kind of a typical text-to-video generation method that is still kind of preparing to show the first frame because it's still generating the entire video. And on the right, you can see COSVID that's generated already 11 videos of the same length, where the latency is 1.3 seconds to get kind of to see the first frame. And the frame rate is 10 frames per second for a 360p resolution on a single H100 GPU. And after 219 seconds, you basically see the video in a typical DAT architecture with a bidirectional. Here is a kind of one application that we showed in the paper, and the sky is the limit here in terms of kind of level of control. Basically here we show that the user can input a text prompt. For example, the camera flies across the beach, and then during the streaming of or the generation of the video, the user decides to change the prompt to, it's moving, turning left and flying over the ocean, and then changes the prompt again to be you fly into the forest, and the model basically corresponds and changes the content during the flight. So you can imagine in the same way we didn't have time for the submission. You can add camera control and character control and motion control and everything in principle should work in real time, which I think again is the future. At the time of submission, Cosmid was kind of the first in terms of quality on this vBench popular benchmark. Of course, since then several methods kind of surpass us. A couple other kind of high quality results. Yes. These two cute dogs running on the street with some neon lights. Bear made of strawberries. And in this case, actually, the video is pretty long because we run it in a sliding window fashion like other generators. It just this one is causal, so we show that we can do the same thing. So you can generate very long videos where, again, you see the first frame very fast. So as part of the kind of code release of this project, we implemented the whole model on a publicly available generator, the 1.2.1, a smaller model, 1.3 billion. And as we did that, we kind of observed a few limitations of this method. One is you kind of see an increasing increase in saturation. As you play the video longer and longer, it becomes more kind of color saturated. And another kind of artifact we noticed is this kind of annoying flickering that you can see on the left side, maybe hopefully on the screen, of the corals on the left. And we were wondering why is that happening, and started kind of investigating. And basically what we concluded is that these artifacts are due to some distribution mismatch between what happens in training and what happens in testing, which we try to solve in the next project. So what do I mean distribution mismatch? So remember, during training, we take a ground truth video, every training video